we are going to do a really quick review, okay? I was making sure it was recording. We're going to do a quick review. So you don't need to write any of this down because you already know all this stuff, okay? So just kind of pay attention and make sure you're on target and you can do all this stuff, okay? So 6.4 was on inverse functions. Okay, inverse functions. How do I find an inverse function? Okay, so switch the x's and the y's, and then what? Solve for y. Okay, and then normally we change that y to an f inverse of x because that states that it's an inverse, right? Okay. Well, did I ask you to do that? Okay. Should you do it? It's not about if you have to. It's should you. That's the way all life is. Once you get to be almost an adult, it's what you should do, not what you have to do. Okay. So if I gave you this equation, y is equal to 2x minus 3, could you find his inverse? Okay. Then you're pretty good. All right. Now, what if I did this? Here's a function. We're going to call it f of x. It has these points. Could you find this?
Sure we can. We don't know how, but we can.
Thank you, Jody. Jody says, people, why are y'all making life so hard? What did you just say that you do up here? Okay, so why are y'all talking about finding slopes and doing all this kind of stuff? How do you find his inverse? What's this one? What's this one? What's this one? Okay. Y'all, there's going to be one on a test, and somebody's going to do this, and then they're going to go, no, that's way too easy. I better change the signs or something. People, that's going to make it wrong, okay? I mean, if you said to find an inverse function, you switch the x's and the y's, then that's all you do. Does it say switch the x's and the y's and flip all their signs around? No, it just says switch the x's and the y's. So switch them. Write it down. There it is. All right, everybody okay? Okay, so what about this, 6.5? 6.5 was square root and cube root. Okay, we just did this yesterday. All right, so what if I give you this equation? F of x is equal to 2 times the square root of x minus 3 plus 1. Okay? What if I said, hey, what's the domain of this function? Could you find it? What would you do? Set it what? What is? There, no. No. What in the world? Where were y'all yesterday? I had class. Yeah. Bailey says take the radicand, whatever is under the radical, and say you must be what? Greater than or equal to 0. And so what does x have to be? Greater than or equal to positive 3. So what is my domain? Perfect. Okay? Hey, anybody know what the range is by chance? Very good. Jada said, hey, this guy right here, he's messing with the y's. He's just going to move that up 1. So instead of being from 0 to positive infinity, he's going to be from 1 to positive infinity. Now, could I graph that thing and make sure my stuff's okay? Yes, I can. Not only do I know how to physically graph it, but you're going to have a calculator, and so you could graph it with your calculator. All right? But did I use a calculator or a graph to do what I just did? No, I didn't. But I am going to check it. Okay? So, tell me, I'm going to start at 0, 0 because that's where the parent function starts. Tell me what to do now. Up 1 and
Over to the right.
right 3. That's my starting point. Now, where's the next point?
2 up, 1 over.
Okay, some kids like to pick a point and plug it in, like a T-chart kind of thing, but, and some kids don't. Here's what I do. I know that next point is up 1 and over 1, but this made it have a what? A what? A vertical stretch of 2. So instead of going up 1 and over 1, I'm going to go and there's my graph. So I look and I say, hey, does it exist just from the 3 over to the right? 1, 2, 3, boom. Yeah. Does it exist from positive 1, where y is 1, and up? Yeah. So this is good. Everybody understand? What if I asked you this? What if I said, hey, tell me what transformations took place?
It was transformed.
Up 1 and right 3. No. What's that called? A vertical stretch. Yeah, at least I tried. A vertical stretch of 2, okay? So, everybody do y'all know what the transformations are? Yes, you do, because that's what we did yesterday, okay? You told them to me. You just told me them then, and then I asked for them, and y'all were like, I don't know. Do I know those? Yes, you know those. All right, let's do one more. One more. What about this one? What if I said f of x is equal to -4 times the cube root of x minus 2 plus 5? Okay? What's his domain?
From negative infinity to positive infinity.
Oh. What's his range?
Negative infinity to positive infinity.
Oh, people, if you miss that, shame on you. Does it matter what I do to that cubic? Does it affect its domain and range? No, it's negative infinity to positive infinity every time. Okay? All right, so let's start today's lesson. Here we go. This is 6.6. Tomorrow, I'm going to teach the extension, which you really already know, or should know. I'm going to teach it again, but I'm not going to go into great detail. I'm just going to kind of refresh your memory, okay? And then I'm going to give you the rest of the class to work on stuff. Monday, you're testing. Monday, you're taking your first part of the test. Tuesday, I'll see you guys, and so you can just use your class time. This class will be, like it always is, an hour long, okay? You can use your time to work on your stuff. I will tell you this, that I gave my second and fourth period classes the option, if they were at school and not doing anything in their classes, that they could come in Tuesday during my fifth period class or my eighth period class if they felt they needed somebody with them while they worked on their review or you know, you see what I'm saying? Well, you don't really have a worksheet, but like the chapter review, if they wanted to study for the test and do some practice problems and they didn't feel comfortable doing it by themselves, I said, you're more than welcome to do it. I said, my fifth period class is fairly big, so eighth period would be better, and I said, but whatever it is, we can work with it. So don't be surprised if some of the kids decide to come in Tuesday, this class period, okay? Tuesday, first, second, and third classes are 55 minutes. Fourth period is 35 minutes, something like that. Fifth period's regular. Sixth, seventh, and eighth period are 30, somewhere around 25 to 35. I don't remember what it is, so I'll say around 30.
Are you going to be our teacher again in the job?
Oh, I don't know, but I'm going to try to not...
You only stayed in there for like 30 minutes.
Oh, I was in there for one whole class period, but then I had class. So this time I'll be in there 2 class periods, first and second. Yes, I do. Very good. Very good. So, well, I do right now anyway. Who knows what happens next year. I could go ahead and put a hammer to fall on me, but anyway. All right, so here we go. We are going to solve radical equations. Solve radical equations. So, now look, I'm going to work 6 examples, so we don't have time to mess around, all right? I'm going to work 6 examples, and they're going to start off really easy and get progressively a little bit harder. The last one, it's a killer. The next to the last one should be easy, but half of you will miss it, okay? So here we go. Example number 1 should be fairly easy. So the cube root of 2x plus 7 equals 3. All right, so here's the issue, guys. Remember how I say if you have an x in the denominator, you can't solve for it? If you're solving for a variable and it's in a denominator, you have to get it out from under that denominator, okay? You can't solve for something when it's in a denominator. Well, guess what? You can't solve for something when it's under a radical either, okay? So I can't pull any. Even if this had been a 27, could I have taken the cube root of that? No, because it's added or subtracted. And added or subtracted can't be pulled apart, okay? Only multiplied.
Can you cube one side?
That's exactly what we're going to do. We are going to cube this side. And what you do to one side, you do to the other side. So a cube root and a cube power, they're opposites, right? So they just undo each other. And what are you left with on the left?
2x plus 7.
And on the right, what's 3 cubed? Oh my word, it's just a dang algebra 1 problem, right? What do we do now? Subtract 7. Well, that's not so bad, is it? 2x is equal to, what's 27 minus 7?
20.
Divide by 2, and what's x? Now, I do need to check these because I'm going to warn you that you can have extraneous solutions, okay? So, just be sure and check them. You want to make sure they're not extraneous, but you also want to make sure that they're right, people, okay? So, I mean, good night. I could just pop it all in my calculator if I wanted to, okay? If you absolutely just go, I hate checking these things. But you don't have to. Like, watch. What's the cube root of? What's 2 times 10? What's 20 plus 7? What's the cube root of 27?
3.
Check. That's my solution set.
We should do a quick little review.
Now, that's not too bad, is it? Okay? All right, let's do the next one. The next one's a word problem. Okay? It's really not that big a deal. All right, but I want us to look at it because I'm not sure that we did something yesterday, and I'm going to use this problem because it's kind of like it. So, in a hurricane, we all know about those, right? In a hurricane, the mean sustained wind velocity, V. What is that? What does that mean? Does that mean it's a very angry mean? The average. Oh, okay. So the average sustained wind velocity, V, in meters per second is given by this formula. V of P. V of P, just like F of X, okay, is equal to 6.3 times the square root of 1013 minus P, where P is the pressure of the air in millibars. Now, we all know what happens to the air pressure when a storm comes, right? It drops. And when the pressure drops, then that's when animals, do they know?
Yes.
Because they can read a barometer?
No.
No. Because they feel it. Yeah, they feel it. And that says, hey, man, you better eat fast because the storm's coming and you got to go take cover, right? All right. So this is my air pressure. This is my velocity with respect to the air pressure. Is the air pressure going to affect the velocity of the wind? Yeah, it is. It's going to tell me what it is. So here's what I want to know. If I tell you that the velocity is 54.5 meters per second, can you tell me what the air pressure is? Okay? Now, I want to show you, did we do the one on the calculator yesterday? No? Okay, I didn't think we did. I thought we kind of ran out of time. So, let's do this one. I'm going to show you. Now, why am I letting you solve this one on a calculator? Because it's what kind of a problem? A real life word problem, and they're just so easy to solve on the calculator, okay? Now this one's a little bit harder only because when you first graph it, you're not going to see anything, but we'll fix that, okay? So let's go to our calculator, and let's go to y equals and clear anything out, okay? I'm going to put that in there. I'm going to put in 6.3 times the square root Oh, stop. We did one on the calculator? Huh? Yeah, okay. So let's see how much you remember. 6.3 times the square root of 1013 minus p, which we're going to call what? X, because that's what it is, guys. All right. And then what else are we going to do?
54.5.
Yeah, what are you going to do with it?
You place it in the y2.
You place it in the y2, 54.5. Okay? And then I'm going to go back to the Zoom 6 because most of the time that's where you guys start.
Place it in the y2.
Uh-oh. Now, what? Is my calculator broken?
No.
Like, I don't see my graph. What's wrong?
Zoom out.
Okay. I'm just looking at a little piece and it's not showing me. So instead of just, y'all, you can always go Zoom Fit. There is a Zoom Fit button. And sometimes it's helpful and sometimes it just is not. And sometimes it gets you close. And you have to figure it out. But I'm just going to start from here. Now, X is the pressure, right? So we're going to start at 0. Does anybody know anything about barometric pressure? How much? Okay, so like how high? Are we talking like 10? Or are we talking like 1,000? 1,000? Okay, so let's go to 1,500. Because, you know, I'm not a meteorologist and I don't really know a lot about it. I am going to go by 150s just because that was easy for me to pick. The scale doesn't really matter, okay? So now y is the velocity. Now we know that the wind velocity can be big, right? Okay? But they told us that we were really just looking at 54.5. So let's just go to 100, okay? Let's go from 0 to 100 and go by 10. Okay, and let's see how good we got. Oh, looky there. That's pretty good. All right, what am I looking for? The intersection. This is my equation, and this is the y equals 54.5. Okay, so I'll go second and calculate. He's going to find the intersection, okay? Don't go over there and try to trace it down, people. You'll miss it by a little bit. So I choose number 5. He's going to ask me some questions. First curve, I don't know where he is. But he must be up here somewhere. But that is the first curve. If I can't see the spider jumping up and down, then I just look up here and it tells me the equation. I press enter because yes, it is. Now he jumps down and he said, hey, lady, is this your second curve? Yes, sir. And now he wants me to guess, and I don't want to play games, so I just say no and press enter. So, intersection. What's the barometric pressure when the velocity is 54.5? Okay, so I've 938.16 or 938.2 millibars, okay? Millibars is what that's measured in. Did I know that? No, the book said it, okay? I didn't know that, people. I'm not a meteorologist, okay? I know it's raining if there's water coming from the sky, right? So that's about the extent of my meteorologist degree. All right. So, everybody okay? Could we solve this thing algebraically? What would I do? Yeah, take this and put it over here. 54.5 is equal to 6.3 times the square root of 1013 minus p. I'm going to start you off, but I'm not going to finish it. Okay? What do I do first?
Divide.
Yeah, y'all make sure that you get this radical by itself before you start squaring, cubing, or whatever, okay? So divide by the 6.3 first. Now, look, do I know what answer we're going to get? Yeah, we just found it on the calculator. It was a whole lot easier, all right? So what's the problems that I can use the calculator on? Real life problems, okay? Real life problems. anything that it says solve algebraically or solve this, then you're not going to do it. All right. So I'm not going to finish. You're going to get something like 8.7. Is that right? 8.65 is equal to this, and then you're going to square both sides and all that kind of stuff. Okay? So I'm not going to do it. All right. Let's do the next problem. Here we go. Example 3. Example 3. Now look, this is the same kind of problem, but they're going to write it differently. Okay? So watch what happens. 3x to the 3/4, nope, sorry, lied, 2/3. 2/3 is equal to 48. Is equal to 48. Arr.
938.20.
Okay, very good. Thank you, Spencer. All right, so what's the first thing that I'm supposed to do? Yeah, y'all listen to me. You've got, it's the same thing. This is a radical. It's a rational exponent. Okay, so we want to get it by itself. So, like Abby said, we're going to divide by 3. And so now I have x to the 2/3 is equal to, what's 48 divided by 3?
17.
Perfect. Well, now what are we going to do? Do what? I can't. I don't know what x is. Oh, Alex says, what if we, powers to powers, what do you do with your exponent? Multiply. What could you multiply 2/3 by, or any number by, and get 1? Because I want x to the first power. His reciprocal. What's the reciprocal of 2/3? 3/2. And what you do to one side, what? Very good. Okay? So these go away, and I'm left with x to the first. Over here, now look, guys, here's a perfect example of what math is all about. Last test, this was a problem on the test. There were people that didn't know how to do it without a calculator. Okay? So, you can do it without a calculator. What's the square root of 16? What's 4 to the 3rd? So a skill that was the problem last test is now just a piece of a problem that we're working. Okay? If we wanted to check it, could we? People, you could go, what is 3 times 64 to the 2/3 power in your calculator? What's the cube root of 64? What's the cube root of 64? 4 squared. What's 3 times 16? It is my solution. All right, anybody got a question? Okay, here we go. Now, example 4 is just like that, but I'm going to add one little skill onto it. Here's what it looks like. X plus 2 raised to the 3/4 power minus 1 is equal to 7. All right, what do I do? Yeah, y'all, all you're going to do, you got to make sure that's all by itself first, okay? So I'm going to add 1. So now I have x plus 2 to the 3/4 is equal to 8. Now what am I going to do? Yeah, raise it to the 4/3 power, because that's its reciprocal. When you raise powers to powers, you multiply. When you multiply reciprocals, you make 1. So this becomes x plus 2 to the first power, which is x plus 2. Over here, what's the cube root of 8? What's 2 to the 4th? What? 16. Square it, square it. 2 to the 5th is 32. 16. Now what am I going to do? Subtract 2. And x is equal to 14. Okay? I'm going to check it. Watch this. What's 14 plus 2? What's the 4th root of 16? What's 2 to the 3rd? What's 8 minus 1? Now, if it didn't check, what should be the first thing that comes to my mind? Yeah, you might have made a mistake. And then when I go back and check it, Marissa, and say, I didn't make a mistake, then I say, oh, you're extraneous, okay? But be careful because wrong answers will appear to be extraneous when actually they're just wrong, okay? All right, here's the next one, example 5. Okay, so now we're starting to get, this is the next to last one, so we're starting to get into some that are going to give some people some problems, okay? So, x plus 1 is equal to the square root of 7x plus 15. Oh, wait, Spencer. No. Okay, now, is the absolute value square root already isolated?
Yeah.
So, can I just square both sides?
Yeah.
On the right, these just knock each other out, and it's 7x plus 15. On the left is where the problem comes in, because your teacher's been trying for 8 months to teach you how to square a binomial, and half of you still can't do it, okay? Very good. Square the first, keep the sign, twice their product, plus square the last. Okay? Now, oh my goodness, the test that you just corrected, it had problems that ended up like this, and then some of y'all said, oh, I got lost there, I didn't know what to do, because I don't know how to solve a quadratic. People, how do you solve a quadratic? What do you have to do first? You've got to set it equal to 0, people. You've got to set it equal to 0. Luke, quick happen. Thank you. All right. So, this is gone and this is gone, so I have 0 on the right. Over here I get x squared, what? Very good. Now, the easiest way to solve a quadratic is to factor it. They don't always factor, but if they do, I'm certainly going to do it. So, this one factors into what?
X minus 7 plus 2.
Okay. Now, if x plus 2 is the factor, what's the root, the solution? Negative 2. If x minus 7, do y'all see what's happening? All that stuff that you were supposed to have learned is coming back into play. X minus 7 is the factor. What's the root? 7. Now, y'all, let me show you something. Because this, I already foresee a problem. All right? And we started with an equation that had x's in it. Do you agree? And then because in order to solve it, I squared it, I created a quadratic that had 2 solutions. When originally it was linear and it had 1 solution. So that makes me go, whoa, I could have made a big problem here. I better check these because one of them could be extraneous. Okay? So I'm just going to check them. You can check them on your calculator. Spencer, you can check them on your calculator, or you can check them. I'm going to check them in the thing. Okay, thank you. Oh, dang it. See what you did? You got him wait. He's all hung up.
The 7 doesn't work.
Okay. So I'm going to try the negative 2. Okay? And all I'm going to do, guys, when you check something, always go back to the original problem. The one on the test, the one in the book, the one on the worksheet. Okay? So this will be negative 2 plus 1 is equal to the square root. What's 7 times negative 2? So that would be negative 14 plus 15. What's negative 2 plus 1?
Negative 1.
This is the square root of 1. What's the square root of 1?
Positive 1.
So, y'all, that's not true. Okay? The square root of 1 is 1. So, negative 2 will not work. It is an extraneous. It is a correct solution that will not check. Okay? Now, let's check 7. Now, if 7 was extraneous too, then I might go back and say what? I might have made a mistake somewhere. I better go back to check my work. All right, this one's going to be 7 plus 1 is equal to the square root of, what's 7 times 7?
49.
What's 49 plus 15?
64.
The square root of 64, is that 8?
Yes.
So 7 is a good answer, and that is my solution.
Can you imagine the headache the person would figure out extraneous solutions have to go through? It's like, why doesn't this work?
Frustrating. All right. So here we go. Here's the last one. Now let's look at this last one, because what have I told you about this last one? Okay, it is. It's a little difficult, takes a little while. So here's the first thing I want to know. I want to know, will I know when it's a difficult problem? Will I know when it's going to take me a little bit longer? Yes or no? How do you know? It has what's different about it? Yeah. He has 2 radicals in it. Okay? Now listen to me. Remember what I say about math. It's very logical. If I can have 1 radical and square it 1 time and get rid of it, if I have 2 radicals, I'm probably going to have to square 2 times to get rid of it. Okay? So let me just show you what's going to happen. The first thing you want to do is make sure that 1 radical is by itself. Guys, it doesn't matter which one. It's not going to affect the answer. This one's already by itself, so heck, let's just do it. Okay? When I square the right-hand side, oh, come on, you stupid thing. It's getting tired. Thank you. Okay, so when I square this side over here, what do I get? And guess what we get over here? This is a binomial squared. So if you didn't know how to do it in example 5, maybe you know how to do it now. So the rules say square the first. When you square this, guys, what do you get? Perfect. See why those rules are important? It's not just because I wanted you to memorize them. It's because it's going to be helpful to you. Keep the sign. Plus. Twice their product. Y'all, their product is 1 times the square root of x plus 2. What's twice that? 2 times the square root of x plus 2. Always plus on the end. Square 1. Square the last. What do you get? 1. Okay, Spencer. We did it again. All right. Let's still. Oh, Spencer, just make a dang squiggle down the street. Thank you. Oh, my goodness. Please. Okay, that's enough. Stop. No.
I was asking the question, though.
All right. So, they're making me hot. Because you're making me precious for time. Okay, so now, here's the object of the game now, okay? Now we want to get this radical all by himself so that I can square it and get rid of it. That's what I was talking about, squaring it 2 times, okay? So the first thing I want to do is I'm going to clean it up and collect my like terms. What is 2 plus 1?
3.
So really this is x plus 3 plus 2 times the square root of x plus 2 is equal to 3 minus x. Everybody okay? Okay, now let's put a little pressure on it. You got 3 seconds, okay? What's your brain going to scream at you to do right here? Yeah, do you? No, okay? Y'all listen to me. Whenever you apply a little pressure, a test, time, okay, then your brain's trying to rush. You just got to calm and say, I got this. All right, we can do it. Okay, so we're still trying to get this by itself. I need to get rid of these 2 terms over here first. Okay? So let's subtract x and subtract 3. And then we're going to see how friendly and nice these people really are. Over here on the left.
Oh, wow.
Try it. No, stop. Stop.
Asking a question.
No. All right. These go away and these go away. What am I left with? 2 times the square root of x plus 2 is equal to 3 minus 3 is what?
0.
Oh, see? Y'all, if that had been a 3 plus 3 or something, this problem would have been a lot more difficult. Okay? So, what's negative x and negative x? Now what do I do? Very good. So now I get the square root of x plus 2 is equal to negative x. Now what do I want to do? Okay, I'm going to square both sides. Spencer, just make a squiggle down the street. I don't have time to mess around. Thank you. Okay, so now I'm going to square both sides. So these go away. X plus 2 is equal to what? Y'all, what's negative x times negative x? Positive x squared. Okay? Oh, my word, y'all. Are y'all okay? Because it's another quadratic. How am I going to solve it? Oh, so I'm going to move everything over there on the right. 0 is equal to x squared. Oh, now what am I going to do?
If you want to, you can pull it out.
What?
I went the other way.
Oh, I'm never going to make a negative x squared because it's very difficult to factor. It takes me, I'm not smart though, but it takes me like 3 times as long, okay? So I'm not going to push my brain, all right? He might blow a gasket. All right, Spencer, squiggle down the road. Thank you. That one on the edge. All right, so I'm just going to factor this into x what? X plus 1, x minus 2. All right? And if it's x plus 1 is the factor, what's the root? X minus 2 is the factor, what's the root? And do I need to check them? Oh, by all means we do. Let's check that negative 1. Okay? Let's check him. What's negative 1 plus 2? So that's the square root of 1 and then plus 1 is equal to the square root of 3 minus a negative 1. What's the square root of 1? What's 1 plus 1? 2. Is equal to, what's the square root of 4? 2. So he checks out. That little negative 1 is perfect. Okay? Let's check the 2. Now look, guys, you don't know that it's extraneous. You need to, don't go, oh, well, that was not, so this one is. Check it. Okay? What is it, 2? So, what's 2 plus 2? So I got the square root of 4. Oh, dang it, pen. Like we were almost through. No. Spencer, quit being so fast. I said squiggle down the road. Thank you. That's it. All right. See, you just got to follow directions. The square root of 4 plus 1 is equal to the square root of 3 minus 2. All right. What's the square root of 4? 2. What's 2 plus 1? Is 3 equal to the square root of, what's 3 minus 2? 1. No. So he's extraneous, put an X on him, and this is my solution. Okay? That wasn't so bad, was it? All right. So you already have your worksheet, and you have problems that you can work on. Okay? Huh? Yeah, and y'all are reading. So read and be quiet.